conversion factors based on how we did them in class that might be helpful to you. So I'm just going to title this Dimensional Analysis. And I'm going to be looking at the worksheet that I gave you for homework over the weekend. It's titled Metrics and Measurement. It looks like it's page 7. Now on the worksheet that I gave you, the examples, some of the conversion factors don't look like the conversion factors that we use. So to begin, I'm going to give you some rules for conversion factors. Let's make this type a little bit smaller. All right, rules for writing conversion factors. The first rule is going to be that your given unit is always going to be on the bottom. Now remember, the unit, it refers to the letters that follow the number in a measurement. Okay. The given unit is your starting point. The second thing is that your desired unit goes on top. Here's some key points. The desired unit is not always going to be the end result. There may be more than one step to solve your problem. Third thing to remember, you have to memorize the prefixes for all the metric units. The prefix is the letter that comes before the base unit. Our base units, if you recall, the base units are things like M for meter when we're measuring length, L for liter when we're measuring volume, seconds when we're measuring time, grams when we're measuring mass, and any other base unit that we could think of to use. Eventually, we're going to be using moles, for example, when we count atoms. All right, I think that's pretty much the basics for conversion factors. So now let's do some problems. I'm going to change the color of the ink for the problem so that there's a noticeable difference. I also gave you some steps for solving dimensional analysis problems. And that's what I'm going to use here. So take out your notes for the steps and follow along. So the first problem I'm going to use is number 1. And it says 35 milliliters equals how many deciliters? So first, let's identify our prefixes and our base units. So in this problem, our prefix is going to be milliliters. Milli is our first prefix, and deci is our second prefix. So let's go back up here and make a note for conversion factors, because we also have to recall that in conversion factors, you should never have 2 prefixes in your conversion factor. So when you see 2 prefixes, like we have in this first problem, that should be a key to you that you're going to have 2 steps. So our first step is going to be to write our given. In this case, it's 35 milliliters. Our next step is going to be times in the dividing line. All right, so we're going to do times and our dividing line. Now when I write the given, I like to have the given written as a fraction, since my conversion factors are also going to be fractions. So I'm going to write it over 1. So my given unit is milliliters, so milliliters goes on the bottom. Now some of you have been writing, would go next and say my desired unit is deciliters. But that's not actually the case. deciliters is not going to be my desired unit because I cannot have a conversion factor that has two prefixes. So actually what my given unit is going to be is liters. Alright, so liters here is my base unit, and milli is my prefix. So base unit, and P is my prefixed unit. Okay, so now we're going to put in the meanings of the prefixes. The meanings of the prefixes. So we always put one with a prefix. So I'm going to put my 1 there. And then the meaning of the prefix goes on top. And milli, we will hopefully remember, is 0.001. Now look at what happened. By putting my base unit having the meaning of the prefix and the prefix having a 1, I have in essence written the relationship. 1 milli is equal to 0.001. Alright, so now all that's left is to do the math. 35 times 0.001 gives me 0.035. But that's not all I have. I need a unit. Well, as I multiply across, because I have milliliters here and milliliters here, they cancel and I'm left with liters. This would be fabulous if I was finished, but I'm not finished because my problem asked me for deciliters. So now I have to do another conversion. So this is my new given, liters. I do times in my dividing line. My given unit in this new step is liters, so I write liters on the bottom. I'm going to deciliters, so that goes on top. I put 1 with the prefix. I put the meaning of the prefix with the base unit, 0.1. Now I can cancel liters and liters. And when I multiply across the top, I get 0.035. I multiply across the bottom, and I get 0.1. So when I take 0.035 divided by 0.1, I get 0.35, and my unit that's left is right here, deciliters. Now some of you are asking yourselves, why does she do it in 2 steps? Because sometimes that might be easier for you to do it in 2 steps. But the other way that you could have solved this all in one would have been to start with your given, 35 milliliters over 1, times in my dividing line. Milliliters goes on the bottom. I have to go to liters. I've already written a prefixed unit. When I already have a prefix in my conversion factor, that means the only place I can go is to my base unit. Milliliters, I'm going to go ahead and cancel. I put 1 with the prefix. The meaning of the prefix goes on top. Now I have liters, but that's not what I'm asked for. I'm asked to go to deciliters. So liters is on top, so it goes on the bottom. I go to deciliters on top. 1 with the prefix. Deci means 0.1. Liters cancels. Now when I multiply, I do 35 times 0.001, which gives me 0.035, divided by 1 times 1 times 1, which is 0.1, which gives me the same answer of 0.35 deciliters. Alright, I'm going to do one more. And I'm going to do problem number 8. Problem number 8 says that 0.005 0.005 kilograms is what I'm starting with. And they want to know how many decagrams that is. Okay, so as usual, we're going to start by writing our given. 0.005 kilograms. And we're going to write it as a fraction over 1. The next step, step 2, is times and my dividing line. Step 3, I write the given unit in the denominator, and I write my desired unit on top. Now here again is a case where I have two prefixes. When you have two prefixes, you have to go to the base unit first. My base unit is the second letter, which is grams. So I have to go to grams first. Now I put 1 with the prefix. The next step is to put the meaning of the prefix next to the base unit. So kilo is my prefix, and kilo means 1,000. The last step is to cancel and multiply. However, I can't do that step yet because I don't need grams, I need decagrams. So kilograms will cancel. I have grams, so now I need another conversion factor. I'm starting with grams, so it goes in the denominator. I'm going to decagrams, so I put that on top. I put 1 with the prefix, and then the meaning of the prefix with the base unit. Deca means 10. Now I can cancel again and solve. So when I solve, I'm going to take 0.005 times 1,000 times 1, and I get 5. In my denominator, I have 1 times 1 times 10, so that's 10. So then I take 5 divided by 10, and I get 0.5 decagrams. And that is my final answer. All right, guys, I hope this helps.